Hello and welcome to the Build Better Homes podcast. I'm your host, Royal Mortier with PLIRIS. And today I'm joined by a professional I've had multiple years working together with, Nate McIntyre. Nate McIntyre comes from the building envelope and construction defect world. I've worked with him on multiple cases as well as consulting on existing and new projects and how we manage, design, detail, and install multiple aspects of building envelope and fenestrations. I thought this would be an important podcast to have as we're seeing a lot of new products come onto the market. We're also seeing a lot of confusion as different things result with the energy code and how these new products integrate in, as well as just what we kind of constantly deal with, which is the construction defects aspects after a building or home is built. So this is very much a knowledge-based podcast. You're going to get a lot of big terms thrown at you. In the end of it, you're going to learn a lot, and we'll be able to provide more information to you guys further on. And I'm sure I'm going to have Nate on here more time. So Nate, glad to have you on.
Thanks for having me.
So I kind of just start with everybody. Give us a little bit of background on you, kind of where you started and how you got into the industry and where you're at today.
Yeah, I started in the industry in the mid-90s, late 90s. I went to work for a mechanical engineering firm and specialized in test and balance and commissioning of air handling systems for high-tech facilities like Intels and hospitals and facilities like that. Started my own business in around 2003, became a licensed contractor, started doing building envelope inspections and construction management around that time. And I've been doing it ever since. So I've worked for multiple national or international consulting services, consulting groups that specialize in engineering and exterior building envelope and building restoration projects, as well as design and oversight of new construction, design assistance for architects and building owners. So the whole gamut of construction for the last 20 plus years.
Very cool. Very cool. So what you do, you didn't actually have to go to college for. You took a different route with experience and then certification. So could we kind of go into a little bit of those?
Sure. Yeah. So I became a licensed contractor in 2003 in Oregon and kind of pursued more of the certification route. So I found around that time they didn't have a building science course available in any of the universities that were specific to the work that I was providing. So there was different areas of expertise. Like yourself, you're a professional structural engineer, and there's a path that you take to get your PE license and provide those things. Same with architecture, mechanical engineers. So they didn't really have one for the building envelope or the building sciences. And so I kind of took the general contractor certification route and applied it to the building issues that I was looking at specifically. And I just kind of get certifications as needed, predicated on projects over the years or whoever I was working for. And it might be a window installation master certification or OSHA safety certification. Specific manufacturers will provide installation certification, those sorts of things. And I just kind of built my resume over the years based on the needs of the projects.
Gotcha. So you really took a in-the-job field experience route in getting your certifications and really just, building yourself up as you are a very sought after building envelope expert now. You kind of started in the trenches and worked your way through it, which, like, from my standpoint, I was a framer and contractor before I became an engineer, and that's massively benefited me as an engineer because I'm able to talk to the framers and the contractors about not just the technical stuff, but really how they implement it in the field. And really that's where you bring the knowledge and assistance here as well.
Yeah, I like to consider myself kind of a general practitioner. One of the things that makes me highly sought after, and I call the building science expert. The word expert is kind of loosely used, but you can be an expert in something. What makes somebody a good expert is knowing who to bring to the table. And so what I do as an expert, as a general practitioner, is I'll look at a building and I'm solving a problem. I'm highly sought after because I'm good at solving problems. And that comes with years and years of experience and knowing how all these things go together, who does what, where, and when, and how it's designed. And then saying, okay, we may have a structural failure. Well, I'm not a structural engineer. So I can look at it and say, well, in this case, we need to bring Royal in. He's going to look at the structure and see how it was designed. What was it designed for? What's supposed to be, what were the design loads? What's the load path? All that fun stuff. Is there a design problem? Is it something that wasn't installed properly? Was there a miscommunication between the designer, the engineer, and the framer? And so I kind of bring those people together. In some instances, usually I'm the guy that says, okay, let's bring Royal in. He's going to solve the structural problem for us, and I'll tell you how the building envelope is working from a physics standpoint. So if we take that and say, oh, well, it's a building failure that has nothing to do with the structure, it has something to do with thermodynamics or condensation, then I come in and show you, I'll show the client, here's the path of air leakage and where things are condensing and why the building envelope isn't performing. Is it a design issue? Is it something that a manufacturing issue, a part that's not working correctly, or is it not installed right?
You know, a lot of people, they look at these things and they think a lot of these elements are mutually exclusive, right? Oh, my building envelope doesn't affect this, or my structure doesn't affect this. Where in fact, with a lot of the new materials that we're working with, or with the more intermixing of materials, we're finding that that's actually not the case at all. We have a situation of the building envelope affects in some cases, how the structure functions, and the structure material can affect how the building envelope and the mechanical systems function. So, like you said, bringing the right experts to the table to have these discussions is really beneficial all around. One example that I'm thinking of right away is a big condo complex that we worked on in Seattle, where you had the building envelope. I got brought in. I also do fire protection. I got brought in on the fire protection issue. But I remember we showed up to it, and the people that selected the siding and the building facade didn't account for the material that they were using for the actual sealing of the building envelope. And so they unfortunately contradicted each other. And so you had a massive building envelope failure. It wasn't the siding that failed. It wasn't the sealing material that failed. It was because we put these two things together and they didn't work together, right?
That's right. So, and that's something that's very common is product incompatibility. And so as a building envelope expert, building science expert, I get asked, well, what is it that you do? Well, I look at these things and I may get retained by an architect that designs a building and says, okay, we don't want it to leak. This is what we want it to look like. Here's generally the materials that we want to use. And sometimes you'll look through the materials and say, okay, well, in that case, you had a rubberized asphalt that got put in contact with a polyurethane sealant. Well, those things, there's plasticizers in the polyurethane sealant that will liquefy rubberized asphalt. And it might be metal. So you might say something that what we see oftentimes is pressure treated components, right? So the structural engineer will say, hey, I want a pressure treated post. And then the architect says, okay, you need to attach these materials to the pressure treated post, but doesn't specify a certain kind of hanger or a fastener. And if you have copper in the pressure treated post and you put a zinc coated nail, well, those things they're far enough on the anodic scale that you get galvanic corrosion. And so that's a product incompatibility that we try to look for in the envelope world, and we catch it a lot in failures. We say, oh, okay, well, they specified the right materials, but somebody didn't order the right fasteners or the right sticky stuff, and it's not working together.
Yeah, you're hitting on something that I don't think, oddly enough, even though this has been the situation for going on 30 years now, of the use of copper napronate and other copper-based pressure treating materials as the replacement for arsenic-based pressure treating materials. It's actually still a very, very common error that we find even in the field today of incorrectly specified connectors or fasteners or hangers. Now, people like Simpson, they've definitely stepped up to the plate, and it's difficult to find anything below a Z-max in any kind of fastener or hanger system that is commonly used with pressure treated materials. So they've kind of they cut the legs off of that. But what you hit on is the galvanic corrosion. I remember one I came out to, and they had large structural bolts going into supporting a massive hanger. There was a lot of load on this outside deck. The deck was maybe 18 months old. And we were actually able to go up and grab what was specified as 5/8 inch lag bolts. And we were able to go up and pull the lag bolts out. And there was no threads left on those lag bolts. None. They had all corroded off. And that's how quickly that happens. So that's a very common one. So there are, I won't dive into the pressure treating. That's a sensitive subject for me because you and I were in the trades when they made this massive transition. And it was because it was in that early 90s that they really started to push to get arsenic out of pressure treated materials. And you can still find them. There's still places that you can get them. They created exceptions for it because it is so superior to the copper and apronate systems. But the arsenic base, and there really is minute amount of arsenic in it, but not anything you or I control, unfortunately. So speaking of new things coming, that was a big push. That was a big new thing on the market. What are some other things you're seeing coming about? Big thing we're seeing right now is the continuous insulation exterior. And then the other one is to try and meet the R values is people going to the spray insulation. And I know you and I have worked on a case before with the spray insulation. So let's maybe start there as far as pros, cons, what you're seeing in that aspect of it.
I get asked this a lot, actually. I have a client that was just asking me the other day is spray foam superior to regular bad insulation? And there's a whole hornet's nest of things that you can delve into with that. I've got a good buddy that is a spray foam rep, and so he thinks you can make sandwiches with it. It works for everything in all instances. And some of the downfalls of it, it's good stuff if you know where to use it, how to use it, why you're using it, and you make sure that the flame spread properties are correct and just scratching the surface. And I'll say some of the things that are of concern with spray foam would be that it's a little bit finicky in how you apply it. Typically, it comes in two parts. And when you put a two-part component together, it has to maintain a certain temperature. They have to maintain a certain temperature and line temperature and the hose where you go to apply the materials. And then you have, like, we go back to what we were talking about with product compatibility. Well, if you're spraying polyurethane or a urethane foam, two-part foam, and it comes on and it's hot, well, what are you spraying it against? And you got to know that whatever the substrate is it going to stick to the substrate? Are there any resins or waxes or anything inside the substrate that aren't going to be compatible with the urethane foam? Do you have wires or plumbing fixtures or pipes in the wall that you're spray foaming to that may have an adverse effect when you apply these spray foam? So these are all things that you got to take into account when you're putting it in. You can't just say, is it good or bad? You can say, here's the advantages to it, that if you put, say, a closed cell foam in a wall assembly, we can say, hey, it's great if it works perfect because it stops air leakage. And we're going to go to that. It's the building science nerd in me. It says, hey, that's good because we don't want uncontrolled air going through your wall assembly, potentially creating convective loops or condensing on exterior sheathings, or down in Florida on the interior sheathings, because it's cold up here in the Pacific Northwest. It's hot, and you have this different drying cycle that happens in both climates. So it's not a good or bad. It's just something that you got to think through. Why am I doing it? How are all these things going to work together to create a whole system? What's the whole purpose? Those are things that we look at when we talk about spray foam, the different kinds of insulation, and even the exterior insulated systems.
There's one thing a lot of people don't account for, and this has been a situation that you and I have seen in multiple cases, is how hot the spray foam gets. It's an exothermic reaction. Well, I'll let you dive into that part of it, because we've seen a situation, I think, where essentially an entire roof assembly that was already constructed had to be fully rebuilt because they didn't account for the exothermic reaction, and it decimated everything. So imagine a large commercial structure that they've essentially put a facade on, not accounting for the fact facade was not resistive enough to what they were putting in, because they had to create a barrier to spray the spray foam against, and it literally decimated the entire structure.
That pre-planning and part of the issues that we see a lot of, that would be a perfect example of something where we'd say, well, the intended purpose of the spray foam was good, but because of the exothermic nature of that spray foam, is you apply it wet, and as it expands and it heats up, it gets really hot, and all those gases start to dissipate. It moves, and then if you got a closed cell spray foam, then that becomes rigid, and you spray rigid foam against something that moves. So we all know, just through thermal expansion and contraction of different materials, everything has a certain rate that it moves depending on the temperature range. And so if you're sticking this rigid foam to something that is going to move, whether it be plywood or it's metal or PVC or plastic, these things all need to move. And if they start moving And you go, well, it's stuck when we put it on and then it moves and now it's unstuck or it causes that damage like you're talking about. In that case, we see that a lot too. So those are things that need to be fleshed out before we just start applying spray foam, saying use this system. You kind of got to think through those things. And one piece of advice that I always give to anybody designing or building or doing retrofitting is get as many people to the table as possible. And so you'll find that a lot of these manufacturers, they've had similar situations to the ones that you and I are talking about. We can say, hey, here's building failures and what caused them and how the stuff that they didn't anticipate. Sometimes if you get a good technical department or product rep, these guys will have seen this stuff. And so I always tell free advice to everybody. I just say, look, anything that you're going to put into a building, call the manufacturer, call their technical department, tell them what you're putting their product onto. If you got two things that are sticky, what are they sticking to? Tell them what you're sticking it to. Do some testing, make sure it works before you proceed with sealing up a building.
And I'll emphasize on that one. I mean, you and I are working on a project right now where it is a situation of bring the manufacturers in, right? If this is right, cool. Bring the manufacturers in, have them tell us this is correct. Because what we're seeing, it's not correct. And that's where, these manufacturers, they have warranties, they have reps. Those reps are trained in this material and they're available to you for free to have these discussions with. If you're using their product, they want to make sure that you're using their product correctly, because the last thing they want is it costs them way, way less money to get that knowledge and guidance into the project in the beginning than it does 5 years from now where there's a failure and now they've got attorneys involved and they're tearing a building apart to figure out what was done wrong.
Oftentimes, as anecdotally, I'll just give you a story of a project in Alaska that I worked on. I got called up. The roof was essentially being torn off the tops of the walls. So it's this big rectangular building. And you've got in this area, there's about 100-degree temperature swing over the year. So anytime you get that big of a temperature swing, stuff is going to move. It's going to expand and contract. And in this case, as the temperatures drop below freezing, the roof membrane shrunk. And as it shrunk, it became like a big rubber band and it just pulled the coping, the tops of the walls off of the building. And they couldn't figure out what's going on. It was structurally sound. We designed it to withstand this crazy amount of uplift, but it couldn't withstand the amount of pressure that was being put on it by this roof membrane. And I looked into it. I looked into the manufacturer's data, and the manufacturer was involved with the design. They were there every step of the way saying, use these parts, do it this way, it'll hold up. But nobody had found, it's called the modulus of elasticity. And so they didn't bother to look at what the expansion and contraction rate of the membrane was that they were putting on. And when that temperature dropped, it just shrunk up so much, it started ripping the building apart. They did the right thing. They brought the manufacturer in and said, hey, we're doing this. Is this okay? The manufacturer said yes. Then they came out later and said, well, you should have read our materials and known that it was going to shrink that much. So no good deed goes unpunished sometimes, but the problem was solved eventually.
Now, the other big item is obviously building sealing, what we're seeing with the energy code changes. And we're working with a pretty large national builder they're making a push towards net zero, but part of that net zero standard is going to a continuous insulation, exterior insulation system. What are you seeing in the continuous insulation world? And then the big one that we're seeing is the zip panels. That's a really common one. And I think there's some confusion or possible misunderstanding as far as how far the zip panels, their system goes.
Yeah, there always will be. Anytime, and that's one of the things that gets confusing about exterior envelope. And I'll kind of digress a little bit. And I had this discussion with a builder just yesterday that each jurisdiction comes out and during construction, they'll look at certain specific items. So, for example, the structural engineer, in this case, you design the structure and the inspector will come out and look at rough framing. They'll look at gang nails and make sure that the hold downs are in place, and they'll do special inspections on those things. They don't really have that for the exterior building envelope. And it's hard for them to do that because there's so many different systems on the market. To your question, the zip panels, that's something that's relatively new. It's been around for a while. And so guys will get this idea that, hey, here's this new system. We can put this on. We don't have to do exterior waterproofing. We don't have to do detailing. It's this waterproof sheathing that's monolithic, and it's the best thing on the market. Usually what I tell people is it's going to be jurisdictionally specific. And even there, don't rely on the jurisdiction to tell you, because the jurisdiction is going to come out and say, yeah, we don't really look at that. As long as it's waterproof and it's not leaking, we don't really care. And they're not really held to any specific standard to that. So then we would go back to, what does building code say? And so if we look at the International Building Code or the International Residential Code, in a nutshell, they pretty much just say if it needs to be waterproof, but there's lots of different ways you can do it. And if you test an assembly to ASTM E331 and it passes and it's not retaining water, then you can say that it's functioning per the intent of the code. So that's one way to do it. I mean, I would tell builders that I get these questions similar to, I think what you're alluding to is that they will come out with a new system and say, well, I've got this zip panel system and the manufacturer told me, the rep said it's waterproof and I don't have to worry about anything. And then you go, well, that's great. That worked in a lab somewhere, but did you test it with all of the parts and pieces that you're putting on the wall, all the cladding in your specific region, to make sure that it's going to hold up and function properly? And so before just taking something and running with it, I always tell people, build a mock-up and test it. That's the least you can do is say, I want to do this. I think this is going to work. Let's test it. Then if it's tested, if it fails, at least you can say I follow building code and this seems to be acceptable. So there's always going to be problems with these systems. And this goes back to EIFS or EIFS, if exterior insulated finish system. That was a big thing in the early 90s when I got into the industry. Most of what I was looking at were EIFS failures. And so exterior insulated finish systems came out and people were gluing foam to the wall. That's an exterior system, like you're asking. And so this is going back to that, but doing it correctly. Because there's been so many failures, we can pinpoint and say, oh, here's where these things went wrong on how we know these don't work. The concept of an exterior insulated wall is a good one. It's moving the dew point of a wall to the outside of a wall, which is great, but it takes a certain amount of skill and detailing and understanding why you're doing it and how you do it, and make sure you have a system that's going to function properly.
What's really put contractors on their heels with a lot of these new products and these new systems is, if it fails, they're responsible regardless. Even if it's a manufacturer failure, a manufactured system. One that I remember was when I was building homes, is we had this caulking that came out that was all the buzz, and the vendors were like, try it on your house and do this and do that. And we went through it and did it all. And then come to find out the caulking was not good and we were having all these failures. Well, guess who was responsible to go through all the houses that we just built and put it in and take it out and put in the stuff that we typically used? We were. And we had to absorb all of that cost. The manufacturer's not on the hook for any of it. And it was obviously frustrating for the homeowners. Here we are 2 years, 3 years after they have moved into their houses. And we're like, sorry, hey, we got to tear out all the caulking that we just put in on your house and redo it all. The EIFS one, that was a huge one. And then because we had a twofer, right? We had the EIFS systems failing. And then we also had a situation, if I'm not mistaken, we had a situation of a massive fungus and mold scenario, especially in the Northwest, where essentially whether it was the spores were in the wood prior to, or it was just because the wood was wet, and then they were massively sealing these homes to not allow any free ventilation. And so the wood wasn't able to dry. So it just molded up horribly. And I was early on in my construction career. My grandfather was also a structural engineer. And I remember seeing massive, beautiful houses having to be burned down because they were so wrought with mold. That was the best way. That was the easiest way to get rid of them. The simplest way to demo the house was to partner with the fire department and do a burn to learn. So it really goes back to know what you're using and making sure that what you're using meshes with everything else.
Absolutely. And then it comes into controls during construction. So it's a process, and I've heard you talk about it, standard operating procedures and planning, and that's what makes you a good engineer. It starts with the developer. It starts with somebody that wants to build a place, then it comes into the design team, and then the general contractor down to the subs, the manufacturer suppliers, the manufacturers, everybody's involved. It takes hundreds of people to build homes or buildings. It takes 10,000 different parts to make these things function properly. And so with all this stuff, if we go back to what's the plan for this stuff, we can do everything we can on the front end and say, hey, here's a good design. Here's manufacturers that have tested, proven materials. And then when it comes to the contractor, what are your on-site controls for protecting materials? I mean, to your point, the wet materials that get sealed in. I had a project a couple of years ago where it was basically 4 stories of a building were sinking into 3 stories below. And I was able to get some drone photos that were taken during construction. And so this thing was deep into litigation, and everybody that touched it was getting sued. And they asked, we don't understand it. What's going on? Is it condensation? And is this thing got a roof leak? So you had multiple experts looking at it, multiple attorneys, and manufacturer, everybody was involved with this thing. And within 10 minutes, I was able to look at the drone photos and show, okay, well, the roof was wet before they sealed it in. So you had this wet sheathing, and they didn't allow it to dry properly. They covered it with a non-permeable roof membrane. They sealed the underside of it with spray foam, so you didn't have any sort of ventilation, no air movement. And this thing just sat and rotted until the building started sinking into itself. That's kind of from a construction standpoint, where we'd say, well, the design was good. Everything, all the products worked together well, but they failed to dry the assembly before they covered it up. So those things happen as well.
Right. Yeah, those are important. Retrofits, remodels, addition. I mean, that's where we have more issues than anywhere else, because we are trying to tie into an existing system, whether that's structurally or building envelope wise. And with the EFIS systems or the stucco systems, we had one house that we worked on. It was over 10,000 square feet, and it had massive differential settlement. So 10,000 square foot house, 120, 130 feet from one side to the other. Differential settlement across the house, depending on the time of year, was anywhere from 4 to 11 inches. So from the high point to the low point, somewhere it was anywhere from 4 to 11 inches. During the year, and the exterior facade was decimated as a result of it. But it was, easiest way to put it, it was very centralized actually, because the movement had occurred in certain areas. And so the homeowner couldn't understand, though, why, as part of the repair with the home, anybody that came out and wanted to touch this was not willing to just fix the sections of stucco that were obviously damaged. It was a complete envelope restoration. And we finally ended up washing our hands of it, because we were working with the homeowner, and he just was like, I am not paying for my entire facade to be replaced. And I was like, well, we're not going to take any liability then. We walked away, unfortunately for them, and I don't know where the house ended up at. But it is a situation of, especially with these building envelopes, trying to tie into something that's existing when the home was 10, 15 years old, applying new to old, you create more issues than what you probably had originally.
Yeah, it's a real challenge. You get it from when you're looking at older buildings and you're retrofitting something in, whether it's a building envelope repair or window replacements or, structural upgrades, all these things. And you go, okay, well, we got new materials. And so you got to make sure the new materials are compatible with the old materials. Then you got to anticipate the movement of those materials. It can get complicated. And to your point, oftentimes, I deal with builders. Really savvy builders will look at these projects and say, I'm not going to touch it, because if I tie into something, I'm buying the liability for the whole building, and I don't want any part of it. So it makes it a challenge for building owners, homeowners, and building envelope nerds like myself. I enjoy the challenge, but there's sometimes that you look at these things and you go, hey, we're going to take our best educated stab at fixing it. And sometimes it's just, you're better off reskinning the building depending on what you're up against.
Right. The size of some of the projects that we work on, it's a situation of, well, you could spend $250,000 patching it and it may work, but then if it doesn't work, you're going to be going down a really nasty path. Or you could spend $300,000 to $350,000 replacing the entire thing, and you got it right and you're good. And unfortunately, people consistently try and go for the cheaper option. And then we're talking to them 5-10 years down the road. It failed. Yeah, we warned you. If it doesn't fail, great. We never hear from you again and we move on with life. But unfortunately, a lot of the time, it didn't work.
That's right. And it's like going to a doctor. If you go to a doctor and he says, well, we'll just pick on dentists. You go to a dentist and he says, well, you need a root canal or I can pull the tooth. If I pull the tooth and put in an implant, I'm guaranteed it's going to work and it's going to last you the next 20 years. If I do a root canal, you might get another 5 years out of it if something doesn't go wrong. And looking at buildings is just, it's a similar thing. You do the cost analysis. I always tell people that they want to know, well, if I go with this cheaper option and I just do it this way, then we look at it and say, well, yeah, these things are proven. If they're not, then here's the risk that you're taking. And it's a cost analysis. Like you were saying, it's $350,000 to make sure that everything's warrantable and fixed properly, or it's maybe half of that and maybe it works, maybe it doesn't work. And if it doesn't work, you're out the money you spent trying to make it work. So you have to do a little bit of a risk analysis on any time you want to retrofit a building.
Yeah, one of my best pieces of advice that I can't remember if I heard it or if I just decided it for myself, but it's way better to buy quality once than cheap 5 times. And I apply that to my jeans, right? I buy a nice pair of jeans. I'm wearing a pair of jeans right now that are over 10 years old. When I bought them, it was the most expensive pair of jeans I've ever bought. But guess what? Over 10 years and they still fit great. They still look great. They still wear great. We're good. I used to be the guy that bought the $25 pair of Levi's, and after a year or two, they're faded, they're frail, they don't fit right anymore because they shrunk or different things. And then you're like, well, all right, well, how many more times do I got to buy more jeans? And then they become a work pair of jeans, right? And buy the quality once, you don't have to do it again. That truly applies to your building. As you mentioned, I'm in Florida. The home that we live in, the builder, he is a very large volume builder. And they actually build a really good quality home. But the thing is that regulations, codes, and requirements for Florida have pushed a significant amount of the expense to the building envelope. And so a lot of the expense of the home is all in the building envelope. So then they have to cut back to be on market or in market for pricing on the interior finishes and facades, which is obviously what you see. You're not seeing all of the things that they went into, the fact that you're not worrying about or caring about the fact that you've got triple pane impact resistant windows, all of them. Your doors, same thing. You've got exterior insulation and blown in insulation, and our roof systems have rigid insulation under the sheathing and then blown in insulation in the attic space and extensive ventilation that's also hurricane resistant and blocked for vermin and all of these things add significant expense to the cost of the construction. And that's one thing that I don't think people realize is just because from a code standpoint and frankly, a construction defect standpoint, building codes and design codes are like comedy. It's tragedy plus time, right? Something tragic happened. We get some time to research why it happened. And then we change our design codes or change our regulations to try and make it to where it doesn't happen again, right? So we have those occur. And that's now our big push is obviously we've got a ton of research into the structural soundness of buildings in regards to wind, seismic. Now we have regulations on hurricane and tornado regions. Now the big thing is how do we make homes more energy efficient, to where the average home is using significantly less energy, and not to mention the home lasts longer, has a longer life cycle of serviceability and maybe what we have. We've got a lot of old homes. I mean, my last house was 1901, but I can tell you, I bought that house in 2014 and had it inspected. The walls had no insulation. So for over 100 years, that home had zero insulation. The envelope, as long as you kept it well painted, it was fine. The walls breathed. Much to worry about decay because everything just constantly dried out. There was nothing to really worry about there.
Self-drying system. I like it. Yeah,
it was great. The house really
very expensive to heat, but yeah.
Yeah. In the winter time when there was a cold breeze outside, you felt it and it didn't matter. So now we obviously don't want that. We want to make cost-effective, efficient homes, but that definitely adds to the expense in the very beginning. Hitting on some things and we'll wrap this up. WRBs, really quick overview of when to use them, when they're required, what's some good ones. WRB stands for weather resistant barriers. It's a constant topic, and I think they're getting a lot of what we're seeing on the residential side of is as people are going to these continuous insulation systems, they're going, well, I used a continuous insulation system or I use zip paneling. I don't have to use a WRB. And I don't know if that's always the fact. So what are your thoughts on that?
Yeah, that's not always the case. Get back to what we were talking about earlier with those systems. I think that, I don't want to give anybody a specific plug. There's some good weather-resistant barriers, WRBs, on the market, whether they're a sheet good, there's liquid applied membranes that are really good, there's peel and sticks, self-adhesive membranes. And, rigid insulation it can serve as a weather-resistant barrier. The problem is that it's panelized and you have joints, and then you have joints and you got openings where you're installing your fixtures. So you got windows and plumbing penetrations, anything that penetrates the wall and the panel joints themselves. And then oftentimes guys will use sealants or adhesives, or they'll use like a tape over the joint. And what you'll hear guys say is, well, hey, that's a weather resistant barrier. It's rated for that. And so, put simply, I always say there's more than one way to skin a building, meet the intent of the code. So if I hear from guys, well, this thing works and we've been doing it and haven't had an issue, I just will always recommend, hey, test it per the building code requirement. That's the minimum. That's the D- standard that you have to meet building code. And as we all know, code is to be a little subjective, and people read it the way they want to read it. I read it and it says the building's not supposed to leak. And if water gets in, it's supposed to have a place to get out. And so I look at things and say, well, if you got a whole bunch of joints in here, panel joints, whether it's exterior insulation or a zip panel, you got troughs for water to sit in, things are going to move, expand and contract, and you're relying on adhesives and you're relying on something that's to be sitting stagnant. Well, it doesn't. It's not in a lab. It's going to be dynamic. It's out in the field. You've got other conditions, whether you're in the Southwest United States, you're in the Southeast in Florida, you're in the Pacific Northwest. These microclimates, they all do different things to the building. And I would never want to downplay a specific system until I see it tested and used in a specific region. It's a long-winded way of me getting around giving you a specific system, because guys will tell you, you can look up buildingscience.com. They've got some really good information. They've got really good stuff in testing, historical data and testing that they've done on different building assemblies. And they'll tell you, here's the perfect wall. It doesn't matter where you put it. It's going to work really well. And most of the time I would agree. I would look at some of these assemblies and go, yep, if you do it just like they tell you and how it's detailed, it's going to function really well. It's going to have a high moisture buffer capacity, meaning that the stuff can get wet, it can dry out, it's ventilated, it's going to function good, it's going to have good energy efficient, weather resistive properties that you're looking for. So, but you got to look at it from a holistic standpoint. You look at the whole building, not just, it's a zip panel, it does everything I want it to do. You got to look at how is the wall insulated and what's the air barrier? Are we keeping air out? I mean, there's going to be a big push in the construction defect market. You're going to see more problems with energy efficiency and air leakage and claims coming out of that from materials not working together, or the unintended consequences of somebody not installing it exactly the way that it was designed, or the environmental conditions where they go, well, this worked really great in a woofy model and it worked good in a therm model, and we've kind of tested it in the lab, but then we put it in this specific region, this microclimate that, boy, we didn't really consider the wind uplift or the UV exposure, and it's caused the building to shift in a certain way, and now it's not working properly. So that's a big, long-winded way of saying, I'm not going to give you the perfect wall assembly. It just depends on the building.
And you alluded to it earlier and seen it before, and maybe you can now dive into kind of the services that you provide to contractors, whether it's contractor or individual home builder or a large developer. But one of those things is actually building mock-ups for these fenestration assemblies, these window and door assemblies, to provide as a guide for the contractor in the field. So you guys provide those, you basically build these mock-ups as a reference point based on like the proposed finishes and window and door assemblies?
Yeah, one of the things that provide is a building envelope reference manual. So, we call it a BERM, and if we provide this to a lot of builders, more so sometimes architects, but typically builders, because we see a lot of is what you see in the construction defect world and construction in general is that the builder will say, okay, I got retained by a developer or a building owner, and I'm going to build something, and they'll send it through. They'll get a structural design. The structural engineer, like yourself, will say, here's the structural design. The architect or a designer will design the facade and exterior finishes and all those sorts of things, and the builder will get these. Sometimes the architectural details aren't really fully thought out or complete, or then we'll have just not an architect involved. And so what we do is provide this building envelope reference manual to say, here's what the design intent was, here's all the materials that are going to be used for the project, and here's items that should be mocked up in the field before you install the entire assembly. And we just make sure everybody's on the same page, looking at the same details, and everything works together properly.
Right. So you've got the berms, and then you mentioned drone photos, and then the big thing that we're seeing now is also these Matterport models. Do you guys work with those at all?
Absolutely. Yeah. So what we came to market with, I like to call it an IVR. So it's an interactive virtual report. And so what I do is get hired on building failures quite often. And so I will go out and model the interior and exterior of a building, and then I'll take all of the product data and I put it into the model. So everybody has a one-stop shop for all of the project information. If I write a scope of repair, I may look at a building failure and draft up a report that shows where the building failed, how to fix it, and all the parts and pieces that I recommend that you put into it. And I will add that to the model, the virtual report. So all of the stakeholders, everybody in the project can get in and see what a building looked like before a failure, what it looks like currently. And then as we progress through the construction, we can add things to it. And so it just kind of has that interactive feel of, you can see the entire building. It's got measurements, takeoffs, floor plans, all these things that typically take a bunch of extra time and are scattered all over. We just put it in one place. That includes drone photos. So I'm a personally licensed drone pilot, and I will go out and take drone photos of a building if it's needed, and I'll add those things to the model. I like to use technology, and you're going to see a push in construction. Some of the newer technologies, the 360-degree capture, the reality capture, digital twins, and just construction capture in general. There's a company called Thor Innovations, and they have a few different technology suites, Resolute and Cartograph. And so what they do is provide cloud storage for 360 capture and construction drawings, and they do this for big data centers and buildings, and encourage contractors, developers, architects, designers to use this stuff. And what you'll see is there's actually going to be a push to get building officials involved as well. So the intent there would be that the contractor or somebody like myself goes out and captures 360 photos of the project through each stage of the project, and then give the building official access to those photos and that data so they can go in and do their inspections off-site. They don't have to come on site and do it. They can send their reports and their notes to the owners and the builders, or in this case, if we have a project where yourself or the structural engineer is out of state and they're the engineer of record, they're out of state, and we can take these models, give the engineer access, he can look and do an off-site inspection, make notes, send emails or whatever communication is set up for the project, and get everybody on the same page as soon as possible.
Yeah, and these systems have actually worked really well. You and I are on a project together right now where we've got interested parties literally spread across the entire U.S. And it's been great with a combination of drone and the Matterport modeling, to provide regular updates to these interested parties, not to mention allowing us to go through essentially room by room. This is a large multifamily system. Go through room by room and assess the different situations. And so you can say, oh, well, in room 302, there's this issue. And, apartment 417, I got this issue. Well, I can literally fly right into the model and see that. And then I can go to the adjoining room and see where it was, say, done correctly, and see where the conflicts are. Or in the case of, like us being the structural engineer, there was truss conflicts. I was able to go right into the model and highlight them in the model and show them to everybody of like, hey, there's a truss conflict here. There's we're missing fasteners here, those types of elements. And it really takes us to another level with construction management. And then, the other part of it is long-term. And this is something, I discuss, is offering this at a larger volume to builders, where we go in ages during the construction and do these models, so that way if there is an issue down the road, they're literally able to pull up the house at its different stages and go, okay, what went wrong? Or, we need to track down where this pipe went, and they pull up the model and go, pipe's right there. And those types of things, just other than going around with a camera and snapping a bunch of photos of your job site, didn't exist before. Now you could literally have a QR code that stays with the house. They scan it and they've got a model of the entire house throughout its construction process on their iPad or whatever they're using, and can go through and figure these things out pretty easily. So it's a cool
That's
system.
right.
I'm really liking where it's going.
Yeah, and it can be used for, like to your point, it can be used for long-term maintenance purposes. There's a lot of things that we use it for. The IVRs are something that I found really helpful recently with it. Anecdotally, I had a water loss case that went out and modeled the building after they had demoed the interior of the building, and I was able to get a floor plan and do measurements with it. And then I was also able to take all of the pre-loss photos, put them into the model, all of the construction drawings, any design drawings, any of the project documents. I could put them into the model and make sure everybody that is involved with the project is everybody seeing the same thing. And so it just makes it for a much easier process. And then in the future of this project, it'll be like you were pointing out, as it's repaired, we will remodel it. We'll go out and do the model at different stages. So you have that kind of a virtual time machine. So you can kind of go back in time and say, here's what it looked like at rough framing. Here's what it looks like with insulation and drywall, and then the finishes. And if anything, when you put that QR code and someone scans it and says, okay, we can go back in time and see where's the pipes, what's the fittings, where's the wire, what kind of wiring's in the wall. Well, you can see it in this model now. You don't have to tear the wall apart.
Yeah, it works really well. And the QR code systems is something that, we've been using those for a long time. I know, consulted on prior projects, you and I discussed, is like hanging like a QR code, almost like a keychain, onto a lot of the equipment, and having that QR code just takes the maintenance people directly to the maintenance manual for that piece of equipment. There's no searching for it or anything like that, or you've got a major database of stuff. We're starting to implement it now on our house plans, where we're actually going to have QR codes on our details. And that detail, or that QR code, takes the contractor to a video of how that assembly is supposed to go together, whether that's an architectural or structural assembly. And we definitely need a lot more people in the construction trades than there are. And so we're getting a lot of young, inexperienced people. And to have that system where it's instead of looking at a 2D line drawing and try and guess what this is supposed to do, I literally can go to a video and somebody's talking me through how to assemble this thing, like an IKEA cabinet.
It's fantastic. It's very, very forward thinking. Yeah, I love it.
Well, awesome. Well, I really appreciate your time today talking about these things. I definitely want to have you on. We got a lot of other things to talk about. The construction defect world is a whole other thing we didn't even really touch on. And there's a lot to discuss in that realm. Thank you, everybody, for listening today. If you would like to listen to more from the Build Better Homes podcast, please like and subscribe to our channels. And you can find us on all platforms podcasts are hosted on, as well as on YouTube. And as always, go do great things.